Hello everyone. Today I will be showing you people how to write macro code in mechanical APDL, and this white bar is where you can paste the macro code, and exclamation marks are comments. So, and this is an example of macro code, and you can see that I have used exclamation marks for future reference and stuff. I will put some exclamation marks for reference, and I will click on file, clear, and start new. Say start new. It will start new database. Say yes. Then go to list files, log file. You can see that code. If you go to bottom, you can see that code has been formed. Just for the clicks you just did. So just copy and paste it in a text file, and we don't need that ANSYS release number and stuff, so I'm deleting that. You can paste this code and see that the same window pops up. Yes, just say yes. Now we'll continue with solving a simple bar problem. So starting with the element type, link, add link 180. Then going to material properties, material model, structural and linear elastic, isotropic, Young's modulus of 200 GP and Poisson ratio 0.3. Okay. Now add sections, section ID 1, and I'll name it as SQ for square, it doesn't matter, and area 2 mm square. Okay. Now if you go to file, log file, and go to bottom, you can see the code has been formed after prep 7. Just copy and paste it in a same text file. There's link NATMP is for material property. There is Young's modulus, there is the square 2 mm square. Now making the model, create key points in active CS, few reference exclamation marks. So in active CS, first one is at 000, then 500, then 1000 coordinates, XYZ coordinates. So now create line and join the key points. So node 1, 2 will be joined by line 1. Okay, apply. Then 2 and 3. Now open the log file again, and just copy the code after reference mark. Paste it in the same file, and I'll just name it as model. Now you can see that K5 is X, then YZ format, XYZ format, and line from node 1 to 2, 3. So next will be meshing. So go into meshing at mesh attributes. Let it be default only, it will be because we have only one element type. And going to size control, manual size, and I'll mesh, I'll divide each line into 2. Then mesh lines, uh, say pick all, so that all the line will be meshed. Now go to log file. From type 1, that is meshing attribute, so copy the code, and let it be those F items, and you can see L mesh stands for line mesh. So now you have to put boundary condition, go to solution, define loads, apply structural displacement. So I'll put displacement on node 1, that is one node 1. All degrees of freedom will be constrained. I'll just type 1, okay. Constrain all degrees of freedom, okay. Now go to log file. You can see that after finish till from finish, the code is for the displacement boundary condition. Just paste it. I'll just comment as boundary conditions. Few more reference marks. Apply force on node, the last node, which is okay. Put force of I'll be putting force of 20 Newton in x direction, fx. Okay. I'll just zoom out a bit and go to log file. Copy the code after the reference marks. Make sure the code is cleaner, and so you can or anyone can understand what part. And the last two lines are formed because of because I zoomed out, so I'll be deleting them. So next we have to solve the model. Go to solve, current ls. Let's say okay. The solution is done. Now thing is, you can even get the code for the code to run the solution. So the status solve with solve. So paste it, then go to post proc, get the deformation nodal solution, deformation in the x direction. Just get the code for that also, so that no need to click every once. After post one, just copy. I'll just say it, comment as a result. Now you can just change the load and copy the whole code, paste it in the command with few warnings to verifications to clear the material property data. So okay, the solution has been done for the load, but just to skip those verification warnings, just put finish so that all the data will be cleared from the material properties. So now if you run this, copy this code and paste it in the command, the code has successfully ran, and you can even see the solution has already been displayed. So you can change the load to 60 and run. It's very easy and saves a lot of time. That's it for this video, and thanks for watching.